Hi everyone. So yesterday NASA had released its first image from the new James Webb Space Telescope, and I had posted a video explaining what it was exactly that you were looking at and giving you a brief overview of the James Webb Space Telescope and its capabilities. So today I'm going to look at the next 4 images that the James Webb Space Telescope team has released to the public. And at the end, I'll also give you an update on the image that we talked about yesterday, which was the galaxy cluster. So let's get started. So the first image that NASA released today was that of the Carina Nebula. Now, what you're looking at in this picture here is the edge of a nearby star-forming region. And the dark regions are gas and dust in the Carina Nebula. And the blue region that you're seeing near the top of this image is actually a large cavity in the nebula. And this has been carved out by the hot, young blue stars near the center of the nebula. And the UV radiation from those stars is creating a bubble inside the nebula, which is that empty blue region. Now, inside the dust and gas near the bottom of the image, you can see lots of stars that were formed from the dust and gas, and also some globules, which is where stars and planets are formed. And this image was taken by NIRCam, which is the near-infrared camera of the James Webb Space Telescope. But NASA also released a second image of this object that was taken with MIRI, which is the mid-infrared instrument. So this is the image over here. And as you can see, in the mid-infrared, the James Webb Space Telescope is able to better penetrate the dust and gas. So you can actually see a lot more structure and detail within the nebula. And that's one of the things that the James Webb Space Telescope does significantly better than the Hubble Space Telescope. It's not blocked as much by the dust and gas in the way, so it allows us to peer into these nebulae and see the structure and see the star formation that's going on inside. So very, very nice image. So the second image that NASA released today was that of the Southern Ring Nebula, which is about 2,500 light years away. What you're seeing in this image is a dying star. The colorful shells of gas are the gas and dust that was expelled by this star in multiple episodes over a long period of time. And it turns out that the central star is actually 2 stars that are orbiting each other very, very fast. And the redder star that you can see in the image is the one that actually expelled all of this gas and dust and created this beautiful looking nebula. And the redder star is actually surrounded by gas and dust, which is why it looks redder as well. And the younger, bluer star is actually quite a bit younger and is in an earlier stage in its life right now. But eventually that star will also die in a similar fashion and create a nebula just like this as well. The third image that NASA released today is that of a very popular object known as Stephan's Quintet. And this is an object that's commonly imaged by amateur astronomers like myself. So this object appears to be 5 galaxies that are interacting with each other. But in reality, the leftmost galaxy is actually much, much closer to us than the other 4 galaxies. So the other 4 galaxies are actually interacting with each other and colliding. But this 5th galaxy on the left is it just happens to be in the same line of sight, but it's not related to the other 4. So the top galaxy in this grouping actually has a very large black hole in its center as well. It weighs 24 million solar masses, or 24 million times as much as our sun. So it's much larger and much more active than the black hole at the center of our galaxy, the Milky Way. And the James Webb Space Telescope actually got the spectrum of that black hole as well using its spectrograph. So what you're seeing in this image now is that the gas that's moving away from us is colored yellow and the gas that's moving towards us is blue. So the color over here allows us to gauge what direction the gas is moving in, and that's a lot like how using the Doppler effect you can gauge whether an ambulance is moving towards you or away from you just by listening to the sound of the sirens. So the same principle allows us to determine whether an object or gas is moving away from us or towards us in space. The James Webb Space Telescope also imaged this quintet of galaxies with MIRI, its mid-infrared camera. And as you can see, that penetrates the gas and dust much better and shows us more detail about the internal structure of the galaxies involved in the collision here. The last image that was released by NASA today is that of WASP 96b, which is a planet orbiting a star about 1,150 light years away. Now, this isn't really an image per se like the others we looked at today. This is more of a chart showing the atmospheric composition profile of this planet. And this planet itself, WASP 96b, is about half the mass of Jupiter in our own solar system, but it's much less dense, so it's about 1.2 times the diameter of Jupiter, so it's quite a bit less dense than Jupiter. And by looking at the spectrum of the light coming from this planet, basically the spectrograph allows you to split the light into its constituents. And by looking at the various absorption lines, you can determine what compounds or elements were present in the atmosphere of that planet. And what we can see from this graph is that the planet has water, clouds, and haze present in its atmosphere. It's also quite a bit hotter than Jupiter or really any of the planets in our solar system. So we don't have any planet quite like that in our solar system, but we were able to get quite a bit of detail just from analyzing the spectrum of this planet. So the James Webb Space Telescope should be able to analyze the spectrum of smaller planets as well, and maybe eventually planets similar in size to the Earth. So we'll be able to get a good idea of their atmospheric composition. And also the James Webb Space Telescope looked at the light curve of this planet as it orbits its star. And what you're seeing in this graph over here is the dip in the light of the star as the planet passes in front of it. And the dip is actually very, very minute, but the space telescope can actually get a very, very good read on the very minute changes in brightness. So you can get pretty accurate information about the size and mass and other properties of the planet. So those were all of the images that NASA released today, but I want to talk a little bit more about the image that I had talked about yesterday, which was of the galaxy cluster SMACS 0723. That was the first image that NASA had released yesterday, and that was the image taken with the James Webb Space Telescope's near-infrared camera, the NIRCam, of this galaxy cluster 4.6 billion light years away. And if you remember from my last video, I talked about how you could see gravitational lensing along the outer edges of that galaxy cluster, which is when the background galaxies are distorted by the gravity of that galaxy cluster, and you can see them as strands or arcs around the galaxy cluster. Now, I've since come to learn that two of the galaxies visible in that image, two of those background arcs, are actually the exact same galaxy. So if you look at this next image over here, which shows the spectrum of that basically pair of galaxies, which happens to be the same galaxy, the spectrum is an exact match. So that tells us that it's actually the same galaxy, but it's basically being shown to us twice. It looks like we're seeing double, basically. So how that happens is that the light from the background galaxy is coming towards the cluster because of the mass of that galaxy cluster, which is bending space and time around that cluster. We see one image of that background galaxy in one area, and then the light's traveling a slightly different path and shows up close to the first image, but still in an arc slightly offset from the first image. So you're seeing two images of the exact same object. How cool is that? And here you can see it in a little bit more detail. So that's very, very interesting. I wonder how many more multiples or doubles we're going to be seeing in this image as NASA gets more time to analyze the data. So I'm looking forward to that. So thank you so much for tuning in, and if you'd like me to do more explanation videos like this of other images that are released by the NASA team, please let me know, and I will make sure to make more videos like this in the future. So if you'd like to be notified the next time I upload a video, please consider subscribing, and clear skies, and I will see you next time.